Hey, welcome to emstatonline. So today we are going to see the application of eigenvalue problems in stretching of an elastic membrane. The previous part we explained what is eigenvalue. A matrix is multiplied by a directional vector, then the system is moved the same direction with some structurable scalar value. That direction is eigenvector, the scalar value is eigenvalue of the corresponding system A. So this problem, an elastic membrane in the x1 x2 plane with the boundary circle x1 squared plus x2 squared equal to 1 is stretched so that a point P of x1 x2 goes over into the point Q of x1 x2 given by y is equal to ax, where a is 4 square root of 8 and square root of 8 6. Find the principal direction, that is the direction of the position vector x of P, for which the direction of the position vector y in Q the same or exactly opposite. What shape does the boundary circle take under this deformation? We are looking for vector x such that y is equal to lambda x. Since y is equal to ax given, so ax equal to lambda x. So a minus lambda into I in x equal to 0. So singular matrix, so determinant of a minus lambda I equal to 0. So we need to find the characteristic equation of the given matrix. The matrix is 4 square root of 8 square root of 8 into 6 this case. A is equal to this one. So 4 minus lambda square root of 8 square root of 8 6 minus lambda, determinant of this one equal to 0. So it's a square 2 cross 2 matrix. So we can use the simple method, lambda squared minus lambda into sum of diagonal of A matrix plus determinant of the matrix A equal to 0. So lambda squared minus lambda, 4 plus 6 10. So this 24 determinant value, 24 minus 8, so 16, that is equal to 0. So we can write the factors. Multiplication is 16, addition is 10. So lambda minus 8, lambda minus 2 equal to 0. So lambda equal to 8 comma 2. So semi major axis 8 and minor axis 2. Lambda equal to 8 and 2. Now find eigenvectors corresponding to lambdas. Here 4 minus lambda square root of 8 square root of 8, 6 minus lambda. Ax equal to 0. First lambda 1 is equal to 2. So 4 minus 2, 2 square root of 8, square root of 8 is 4 into x1, x2 equal to 0. So from this one, 2 into x1 plus square root of 8 into x2 equal to 0. Square root of 2x1 plus 4x2 equal to 0. From this equation, 2x1 or square root of 8x2 equal to minus 2x1. So x2 equal to minus 2 by square root of 8x1. Obvious. For instance, x1 equal to 1. So 1 minus 2 by root of 8. So 1 minus 2 by root of 8 is eigenvector corresponding to lambda equal to 2. Now find the angle tan inverse x2 by x1. So this tan inverse x2 is minus 2 by root of 8 by 1. In this case, minus of tan inverse 2 root of 8. This minus 35 point, that is 180 minus 180 minus tan inverse of 2 root of 8. Use calculator. 180 degree minus 35.264 degree, and this one is 144.73 degrees. Now find lambda equal to 8, the corresponding eigenvectors. So 4 minus 8, 4 minus 8, square root of 8, square root of 8, 6 minus 8 into x1, x2 equal to 0. So this value is minus 4 x1 plus square root of 8 x2 equal to 0. Square root of 8 x1 minus 2 x2 equal to 0. So from this equation, square root of 8x2 equal to 4x1. So x2 equal to 4 by square root of 8x1. Instantly x1 equal to 1. So 1, 4 by square root of 8. So corresponding lambda equal to 8. So now find theta. Tan inverse of x2 by x1, tan inverse of x2, that is 4 by square root of 8 by 1. The angle use calculator, 54.73. So 54.73 in the first quadrant, 144.73 in the second quadrant. It's a principal direction angle. So now these vectors make 54.73 and 144.73 degree angles with the positive x1 direction. They give the principal direction. The eigenvalue shows that in the principal directions the membrane is stretched by lambda equal to 2,8 respectively. Accordingly, if we choose the principal direction as a direction of a new Cartesian u1 u2 coordinate system, say with the positive u1 semi-axis in the first quadrant and positive u2 semi-axis in the second quadrant. Of the x1 x2 system. And if we set u1 equal to r cos theta, u2 equal to r sin theta, then a boundary point of the unstretched circular membrane has the coordinate cos theta and sin theta. Hence, after the stretch we have Z1 is equal to 8 cos theta, Z2 equal to 2 sin theta. Since cos square theta plus sin square theta is equal to 1, so squaring and adding on both sides, Z1 squared by 8 squared plus Z2 squared by 2 squared equal to 1. This shows that the deformed boundaries is an ellipse with the principal semi-axis 8 and 2. This principal direction. The geometrical representation is a unit circle so here semi major axis 8, minor axis 2, the ellipse just like this, the elastical membrane is stretched this one and with the direction, the principal directions here this angle is 54.73, this angle is 144.73. So these are the principal directions. Here it's a principal direction. With semi major axis and minor axis too.